Performing pump station hydraulic tests will allow you to calculate your station's actual pumping flow rate, as well as help you identify and diagnose possible issues in your pumping system. As with all technical procedures performed on any pump station, ensure that you are following your employer's safety guidelines. Be sure to review the provided Smith Loveless O&M manual and be aware of all safety signs furnished on your station. The pump drawdown test procedure is used on Smith & Loveless's line of Everlast pump stations. First, determine static head and total dynamic head. To do this, 2 pressure readings and 1 measurement are needed. Tech tip: to avoid leakage of sewage into the pump station, close the pump discharge isolation valves when connecting and removing the test gauge. Measure the vertical distance from the center line of the volute to the bottom of the cutoff float. Round up to the nearest half foot. This is your vertical suction lift. Close the pump discharge valve of the pump to be tested. Identify the compound gauge on your pump discharge nozzle. If you do not have one currently installed, you will need to install one at this point. Open the pump discharge valve of the pump to be tested. Wait for a pump cycle to begin and then record the PSI while the pump is operating. This is your pump discharge nozzle reading. Multiply your pump discharge nozzle reading by 2.31. Doing this converts your measurement to feet of water. When the pump completes a cycle, close the pump discharge valve. Now install the compound gauge on the check valve. Open the pump discharge valve and record the PSI. This is your check valve reading. Multiply your check valve reading by 2.31. This will convert your measurement to feet of water. To determine total dynamic head, combine your vertical suction lift and your converted pump discharge nozzle pressure reading. This is your dynamic head measured in feet of water. To determine static head, combine your vertical suction lift and your converted check valve reading. This is your total static head measured in feet of water. Now that you've determined total dynamic head and static head, you need to determine present pumping rate. To do this, you will need to measure and record the diameter of your wet well. When the lead pump starts pumping, measure the distance from the top of your wet well to the water level. This is the on-level measurement. Allow the pump to complete a cycle. When the system stops pumping, measure from the top of the wet well to the off level for the off-level measurement. To determine the height of the pump's operating volume, subtract the on-level measurement from the off-level measurement. Determine your pumping volume with the following formula. 5.87 times wet well diameter squared times the height of the operating volume. Note that this formula has converted your volume from cubic feet to gallons. Tech tip: this formula is specifically to be used with circular wet wells. For non-circular wet well formulas, contact Smith & Loveless. The pumping rate for your station will be a measurement of gallons per minute. To determine your pumping rate will require both a quantity of volume and the amount of time your pump requires to complete a pumping cycle. Tech tip: the time measurements taken will have to be in minutes to correctly evaluate your station's performance. To convert from seconds to minutes, divide the number of seconds recorded by 60. For example, 1 minute and 30 seconds converts to 1.5 minutes. Record the amount of time required for the pump station to pump down from the on level to the off level. Start your stopwatch when you hear the vacuum pump turn off and the wastewater pump turn on. Stop your stopwatch when you hear the wastewater pump turn off. This is the amount of on time. Record the amount of time required for the pump station to fill from the off level to the on level. Start your stopwatch when you hear the wastewater pump turn off. Stop your stopwatch when you hear either the vacuum pump turn on or the wastewater pump begins to pump again. Record the amount of off time. Tech tip. For best results, time the operating cycle during a period of fairly consistent flow into the well. Also, the flow into the pump station will vary throughout the day, so for the best measurement of your pump station operation, we suggest performing this test at different times of the day. Finally, calculate the pumping rate with the following formula. Divide your operating volume by both the on time and the off time, and combine those two numbers. This will be your pumping rate in gallons per minute. The total dynamic head and flow rate should be close to the design conditions on the engineering order in your O&M manual. If one or more of these numbers is significantly different than in your O&M manual, please contact Smith Loveless.